All right, welcome back, everybody. Today we're going to be spending our second day talking about the properties of parabolas. Our objective is that we can identify all major properties of a parabola if we are given the graph. We're going to work away from getting the graph, so right now let's just take advantage of it while we have it to sit there and really solidify these ideas in our head as to what each of these things are. Yesterday we opened up by discussing this for the first time. Today's kind of like a second pass, and it's a chance for us to ingrain that information deeper into our brains. So looking at this, remember, we have a couple of different key components. One of the first things we always look at is the vertex. The vertex is always the highest or the lowest point that your graph hits. In this case, our vertex is a minimum because it is a low point, right? Now, our vertex is also always, it should be written as a point. Written as a point. So anytime you're always going to write it like x comma y for your vertex. Couple other pieces that are important. The next thing we normally ask you about is the axis of symmetry. So the axis of symmetry, you can see it in our drawing right here, and it's pointing to this dotted line right here. Remember, the axis of symmetry is that line on which you could fold that parabola and it would land exactly on itself. Now, anytime you're going to write the equation for the axis of symmetry, you're always going to write x equals a number. And the number you're going to write is the number that your axis of symmetry passes through on the x-axis. So in this case, our axis of symmetry would be x equals 1. What other pieces do we have to consider? So the other pieces that I see here that are worth noting are the x-intercepts that we can see listed right here and here. Anytime you're talking about x-intercepts, you want to write these as a point as well, right, as points. And let's even give you a reminder, x comma y. Anytime you write a point, it's always x comma y. And then along with the x-intercept, we also have the y-intercept. So coming over here, the y-intercept is where our graph crosses the y-axis that we can see right there. Let me maybe do that in a different color. So it's where our graph crosses the y-axis. So we can see that it crosses right there. And the y-intercept is also written as a point. So again, that's going to be x comma y. Now, one of the last things we talk about is whether our graph is opening upwards or if it's opening downwards. And in this situation, we can see that our graph is opening upwards. So what we like to say is we like to say that our graph is concave up because it's opening upwards. If it was opening downwards, then we would say it's concave down. Let's look at another graph here. So here's a new graph for us to consider. It says, based on the graph of the given parabola, identify the vertex, the axis of symmetry, the x-intercepts, the y-intercepts, and determine its concavity and if it has a max or a min. So the first thing it wants to tell us about is the vertex. So in this problem, I can see my vertex is right there. It's always that high point or the low point. And remember, when we write this out, we always want to write it as a point. So it looks like the x-coordinate of our vertex is 5. And it looks like the y-coordinate of our vertex is negative 25. So 5, negative 25 will be our vertex. Now, after that, it wants to know about our axis of symmetry. So if we continue this dotted line, right here, our axis of symmetry is kind of that fold line, and it always passes through our vertex. So it looks like, remember, this is always written as x equals a number. Since it goes through 5, x equals 5 will be our axis of symmetry. Now, after that, we do need to also identify the x-intercepts and the y-intercepts. So it looks like our x-intercepts, remember, that is where our graph crosses the x-axis. So it looks like we have a crossing point right here and a crossing point right there. Those are our x-intercepts. Now, it looks like our first x-intercept passes through the origin. So we're going to say that our x-intercept happens at 0, 0. Our other x-intercept happens when x is equal to 10. So we're going to say that that is at 10, and then the y value of that point is 0 as well. So 10, 0. Now, for our y-intercept, we want to know where does our graph cross this line. And it looks like it actually crosses at the same point as it was for our x-intercept. This is our y-intercept. So since it's at the point 0, 0, we can come over here and say 0, 0. Now remember, whenever we ask you about concavity, we're just asking, does the graph open upwards or does it open downwards? And in this situation, our graph is opening up. So we're going to say that this is concave up. Last but not least, we're just asking you does your graph have a high point or a low point? And right down here, this is definitely a low point for us. So we're going to say that this has a minimum. Now, there's definitely a pattern between if your graph is concave up and what this value is going to be. I'll let you look for that pattern, but that's definitely something to be aware of. It might save you a little bit of time. Here's our next one. So looking at this graph, let's first identify our vertex. Looks like our vertex is located right here. Now, let's actually just jump around a little bit. In this problem, we can see our graph's opening downwards. So we're going to say that this is concave down, because we're opening down. Looking at your vertex, we can see that our vertex is at the very tip top, which means it's at a high point, which means that our graph has a maximum. So our graph is concave down and we have a maximum. Now remember that that maximum value that our graph hits is also the same as what the vertex is. So our vertex of this graph would be at the point, well, it looks like our x value there is 0, and our y value is 1, so this would be our vertex. So we can say 0, 1. Now, if you recall, anytime you're talking about the axis of symmetry, we are talking about the line that goes through the vertex that runs vertically like this. Anytime you want to write the equation of that line, you're always going to write x equals, and then it's whatever number you pass through. This one is between 1 and negative 1, so it must be going through 0. Now, don't forget, your intercepts are where your graph crosses the x-axis, right? So it's where our graph crosses the x-axis, which we found here and there. Those should always be written as points. So we can have negative 1, 0, and 1, 0. 0 is always the second value in our x-intercepts. That's worth knowing, I think. The last thing is our where we cross the y-axis. So our y-axis is right here. It looks like our crossing point is right there. And it looks like that's the same as our vertex, which is unique. But this is also our y-intercept. Sometimes points on your graph are going to have more than one meaning. So in this situation, our y-intercept happens when x is equal to 0 and y is equal to 1. So our y-intercept is 0, 1. And just like that, we've been able to go through and list everything we needed to. Nice job. For your homework, there are 4 problems down here that you guys are going to tackle and complete. If you have any questions, please make sure you're reaching out. It's really important that we understand this stuff. Thanks, guys. Have a great day.